we're going to use a ratio test to determine the radius of convergence. And then we have to, if there are endpoints, we're going to have to substitute in x's, the endpoint x's, and determine the interval of convergence to see if the endpoints converge or diverge. And at that point, we're going to have to use some other tests for the limits. Okay, so we're going to start off with our ratio test to find out the radius of convergence. So we're going to do 1b. So in 1b, what we're going to do is we're going to take an plus 1. So we're going to put that term into n plus 1. And then we end up with 3x plus 1. And then our exponent is n plus 1. Okay, so we're going to then put the original an in there. So n 3x plus 1 to the power of n. Okay, so once we establish that, we're just going to group some of these together. So we're going to group those together. So the limit of that looks like it's going to be 1. And then we're going to group these together. Okay, and that's going to give us the ends, the 3x plus 1 to the ends are going to cancel out. So we're going to end up with something that looks like this. The limit as n approaches infinity, and for the n parts, we're going to get n plus 1 over n. That's going to work out to be 1. And then for the other part here, we're going to end up with 3x plus 1 times 3x plus 1 to the power n. Okay, so the plus 1 we're going to just leave as 3x plus 1. And then the denominator, we have 3x plus 1 to the power of n. Okay, we can see that those terms are going to cancel out. We can apply our limit. The limit of n plus 1 over n as n goes to infinity is equal to 1. And we end up with 3x plus 1. And we need that to be less than 1. Okay, I got to put my absolute value around here because at this point we need to use these absolute values to determine the endpoints. Okay, so we end up with 3x plus 1. That has to be less than 1 and also greater than negative 1. We're going to do this in two parts. So I'm going to find the left endpoint by solving for the x value here. So I end up with negative 2 is less than 3x. So negative 2 over 3 is less than x. So this represents my left edge of my boundary. So this is the left edge of the radius. And then I'll solve for this one here. And so we end up with 3x is less than 0. I'm going to subtract the 1 from both sides. So we get x is less than 0. Okay, that represents our right edge endpoint. So our radius is going to have a center, and we can take a look at that expression there is going to determine the center. C is equal to negative 1 over 3. And we can see based on the edge, right edge and left edge, that my radius is going to be equal to 1/3. Okay, 1/3 to the left, 1/3 to the right. So we could say plus minus 1/3, but the radius is 1/3 with a center at negative 1/3. Okay, so that is my interval so far. At this point, we now have to test endpoints to see if the endpoints are part of that interval. So we need to test endpoints. So I'm going to test the endpoint x equals negative 2 over 3. For that, we're going to go back to the original expression. I'm going to plug that x value into that expression. So I need to see if the sum of 1 to infinity, in this case it's 0 to infinity, of n times, when I plug the negative 2 over 3 into for the x, I get 3 times negative 2 over 3, that's negative 2, plus 1 is negative 1. So what I end up getting is negative 1 in the base, and then to the power n. So this negative 1 is very nice to have because it makes it alternating. However, even though it's alternating, it's going to go, the n is not going to 0. So we're going to go from 0, 1, 2. It's just going to get bigger and bigger and bigger and go from negative 1, positive, back to 0, negative 2, back to 0, etc. Okay? So this will not converge. Okay, actually, that's not quite true. If we start at 0, we get 0, n equals 1, we get negative 1, n equals 2, we get plus 2, so that we go negative 1, 1, and then we can add those all up. Regardless, that n keeps on increasing. This is divergent. Okay, so our interval so far is going to be negative 2 over 3, and it's got to be bigger than that. And then we need to test our right edge endpoint. So when we're going to test x is equal to 0. So we need the sum of x equals 0 to infinity. When we plug 0 in, we get n. And I plug 0 in, I just get plus 1 to the power n. Again, this just gets bigger and bigger and bigger. This is also divergent. So the endpoint does not converge, so we can't use that endpoint either. So it's not equal to 0, it's just less than 0. So when we test the endpoints, we're testing to see if we can make it equal to the endpoint or not equal. In this case, both divergent results lead us to just x is greater than not equal to, x is less than not equal to because of that divergent. If it was convergent, then we can then add in the equal to's onto those. Okay, but that's not the case here.